Now we already talked about examples of graphs which is not continuous, and among them I spoke about a jump discontinuity. Actually, all kinds of discontinuities have names in there, and you have to know the names. So let me explain those names. First is the one that we already talked about. You may have a function have a jump, okay, going up or going down. So it's a jump going down. In this case, you call this a jump discontinuity. In fact, every time a left limit is not equal to the right limit, it's called a jump discontinuity. Now, another type of discontinuity is when the function value is not defined, or when the function value is not defined, the function value is defined, but its value and the limit is different. So this is an example where the function is not defined at this point, so there's a hole. This one, the value is up here, but that's different from the limit, right? Now, whenever you have this type of case, these two have similarities because there's something called this R pod, this circle with two whiskers going left and right. That's called R pod, and it really means removable point of discontinuity. Okay, RPOD means removable point of discontinuity. It's an acronym, and because it looks like a pod, it's really easy to remember RPOD. Okay, so whenever you see this small circle with two whiskers coming left and right, that's RPOD. This one is not an RPOD because it's only extending to one side. Okay. Now this type of discontinuity is called removable discontinuity because it's actually, among all these discontinuities, it's the most treatable. It's the easiest to treat kind of discontinuity. See, when you do calculus, a lot of times you want the function to be smooth and it's all connected. Those functions are the most well behaved. And whenever you have these discontinuities, you always have to be careful about these things. And so there's always this desire to make a function that's not continuous into a continuous function. Now, for the case of where you have a removable discontinuity, you can remove that discontinuity by filling in that point like that, or when the definition is different, you just bring this down here. So you just have to move one point to make it continuous. So that's where this name comes from. And lastly, if you have a graph that has vertical asymptotes going up like that, right? Or if you have something that's going down and then like that, these are called infinite discontinuities.